Hi everyone, my name is Harshit Sani.
And my name is Robert Edmiston. We are part of the Teachers in Space Incorporated Space Frontier Foundation community.
And the title of our experiment is a study of how microgravity affects the enzymes in amyotrophic lateral sclerosis using the model of pathbane and gelatin. Next slide, please. So, our inspiration for this experiment was our teacher and coach, Jason Whitworth, who was diagnosed with ALS in the fall of 2011. His diagnosis drove us throughout this project, and in honor of him, we call this project Project Whitworth. Next slide.
So, glutamate is an amino acid, and it's used as a neurotransmitter. It's normally found in like the synapse between two different neurons. It's a naturally occurring amino acid, and everyone has it inside of them. Next slide, please.
In ALS patients, glutamate does not break down properly by enzymes. It builds up to a toxic level, which causes the motor neurons to die. And in return, this results in the loss of voluntary muscle controls that you see in ALS patients. Next slide.
So the way enzymes work is it's kind of like a lock and key. So you have like a substrate and then the enzyme, and it only fits in one way, and only one enzyme or one substrate fits in one enzyme. So like if it fits this way, it will not work. If the same right substrate comes in this way, it does not work. You have to have it like this. So when that happens, then the substrate breaks apart into smaller, more usable pieces for the body. And then the enzyme is able to be continually reused and recycled so that it can continue breaking down for the body. Next slide, please.
So our hypothesis was that enzymes would be more effective in space. We based that on the fewer restrictions that would be present for the enzymatic pairings because of the lack of force of gravity present in a microgravity situation. Next slide.
So we were fortunate enough that NanoRacks allowed us to use a type 3 FME. So in the first volume, we placed our pathbane, which was our enzyme. In volume 2, we placed our gelatin, which was our substrate. To activate the reaction, all you have to do is undo clamp A and shake for 20 seconds. And then in volume 3, we put our ascorbic acid, or vitamin C, which this basically stopped the reaction and shut down the enzyme so that we could get an accurate reading of the protein that was left. So to activate that, you just undo clamp B and shake for 20 seconds. Next slide, please.
Now the moment of truth, the launch. So, our project launched January 9, 2014 from the Mid-Atlantic Regional Spaceport in Wallops Island, Virginia. It launched on an Orbital Sciences Antares rocket and delivered by the Cygnus ferry vehicle. During the launch, we had students from our high school as well as some ALS patients present, and we waited in much anxiety as this launched into space. All right, next slide.
We were even fortunate enough to have launch control give a thumbs up to Coach Whitworth, because yes, they heard about him. We got a thumbs up from the director of Goddard, the chairman and president of Orbital, and the ISS program manager, so he's like in charge of all of the ISS program. Next slide, please.
So, our experiment on the ISS. Our experiment was initiated by astronaut Mike Hopkins on March 5th, 2014, and it was terminated by astronaut Koichi Wakata on March 8, 2014. The total runtime was exactly 3 days, 3 hours, and 59 minutes. Next slide.
So I guess a couple of the astronauts heard about Coach Whitworth, and astronaut Rick Mastracchio sent out a little words of thanks to Coach Whitworth, which we thought that was really awesome. Next slide, please.
So this was our ground experiment. On the ground, we initiated our experiment on March 7, 2014, and our experiment was terminated on March 10, 2014. The total runtime, just like in space, was exactly 3 days, 3 hours, and 59 minutes.
Next slide, please. So the experiment returned to Kazakhstan via the Soyuz on March 11, 2014. And what we thought was really cool about this was it actually brought back Mike Hopkins, who was the one who initiated our experiment. So it was really cool that the astronaut that started it came home with it. Next slide, please.
So our experiment shipped from Kazakhstan to Houston, and then finally back to Melbourne, Florida, where we anxiously opened it along with some of the members from the ALS support group from our community. Next slide.
We tested the FME with a Buret protein assay, and that helped us determine the levels of protein that was still left in the FMEs. Next slide, please.
So we used a device called a spectrophotometer to determine the amount of remaining protein by measuring the absorption levels of each individual sample. Next slide.
This is our data that we collected. On the next slide, you get a much better representation, so can we please get the next slide?
All right, on this slide you can see a bar graph. The four samples on the right are the ones that we conducted on the ground, and the one on the left is what we had in space. We were very happy with the results. It was astounding that we found 40% more efficient breakdown of proteins in space than we did on Earth. This was completely unprecedented for us. Next slide.
So we ran our data through the ANOVA statistical analysis tests, and we found that the two groups were statistically significant, which was really awesome. And like my partner here, Sunny, said, it was about 40% more efficient in space than it was on Earth, which was exactly what our hypothesis was. And we were ecstatic that we actually found some pretty good support for what we thought was actually going to happen. Next slide, please.
All right, we would like to give a big thank you to all of these organizations and groups that helped us throughout this project. And we would also like to give a big shout out to our teacher, Ms. Amy McCormick. This project would not be possible without her. And a heartfelt thank you to Coach Jason Whitworth, who has been and will always be in our hearts, giving us hope and leading us on.
Questions for the teachers and space team.
Ronnie from New Jersey in Long Branch. My question is, do you think that if this was put into market, do you think that it will help many other patients and be used very?
Well, as things stand now, of course, it's not very possible to send out anyone up into space without, them being an astronaut already. But commercial space flight is becoming much more popular, and it is taking off. And in the next 2 decades, we could see some actual usage for these kind of experiments. So we're really looking forward to that.
We also think about the liquid thing that the NanoRacks guy was talking about yesterday, where we took the liquids and took them out of their element, and now we're learning more about liquids. That's kind of what we were doing with the enzymes, but we're trying to learn more about how enzymes work. So we kind of already know how they work on Earth, but then if we put them out of their element, we can learn more about the enzymes.
My question is, do you plan to continue your research on it?
We plan to continue helping as much as we can. Both of us are actually in college right now. We're going into our sophomore year, so it's kind of hard for us because we both live about 3 hours away from our old high school. So it's kind of hard for us to get back and assist, but we help any possible way that we can, and anything moving forward that they need help with, we're most definitely going to jump right on board and help them.
And not only that, but we also want to be a big part of the ALS community. We're not going to stop there. We have tons of momentum right now, and we're going to continue with it.
Professional research teams, they move from institution, the researchers move across institutions, but they find a way to collaborate because this is their passion, this is their profession. And you guys are how far apart now?
He's at University of Florida, which is about 2 hours north of where I'm at. I'm in St. Petersburg.
And you found a way to come to this conference and present your results.
Yes, sir, we did.
So with that, we are concluding the oral presentations for the 2014 conference. Thank you.